For this video, we're going to take up the homework on the instantaneous rate of change. So I had 4 functions here. I basically set up my table, and then I solve for the secants, the slopes of the secant, which will help me approximate the slope of the tangent at x equals 1. So the first one, I actually didn't need to do all this work. I did it anyways just to show you, but I really didn't need to because this is a line and the tangent will always have a slope of 3 because the slope of this line is 3. And I arranged my table differently compared to the lesson. I put delta x first and then delta y, so please don't get confused by that. So for the first example, I approach from the left side. And the second one, I also approach from the left side. And remember, we do not know for sure that the slope of the tangent line is 4, for example. So all we're going to say is we're going to approximate. So even if you know for sure, let's just say we're approximating, because this method does not ensure that the slope of the tangent line is indeed 4. Okay, we don't have that knowledge. We're just approximating. So the slope of the tangent line, or the instantaneous rate of change at x equals 1, is 4, or approximately 4, sorry. For C, we have some interesting function here. No problem. We can still find the instantaneous rate of change at x equals 1. So once again, I approach from the right side. I personally prefer to approach from the right side, but that's just a personal preference. So it's about 1.295. And for D, I finally approach from the from the right-hand side, but nonetheless, it's 1/10, 100th, and 1,000th away. And then solve for delta y, solve for delta x, calculate the slope of the secants, and then use the trend and approximate the slope of the tangent line. And if you're still having trouble with that idea, really use the animation and help you, because it's pretty evident that the secant line is very helpful when it comes to approximating the slope of the tangent line.